Ladies and gentlemen, today is Thursday, August 22nd, and welcome back to another game dev stream. I am Maru Dark. This is Circuit Studios, and we are just coming off of the GMTK Game Jam. Yesterday we reviewed a whole bunch of games that people submitted, giving feedback and reviews in real time to some of the developers. We got through over 25 different games. If you would like to see that, we have the VOD will be a bit available. It's about 12 hours long from start to finish with a couple intermissions in between. And next week, starting on Tuesday, is going to be the Sasquatch B Game Jam 2024. So while Mark is streaming reviewing entrance to his game jam and we're waiting for the results of judging, we here at Circuit Studios are going to be preparing for the next one. Some of you may be wondering, how do you prepare for a game jam exactly? Well, it turns out that voting for the theme was opened up to the public, and let me bring that up real quick. One second. So these are some of the potential ones, along with the ones that I had submitted as my personal preference. So one thing that you can do, if you know ahead of time at least what some of the potential themes are going to be, you can start to generate ideas for that. But we are not going to be focused on that today. Instead, what we were going to focus on is the fact that the competition is being sponsored by Genies, who makes customizable characters and 3D assets. So we know that it's at least going to be a 3D game, since we have to use some of these skins in all of our submissions. And so far only 117 people have joined. So we'll see that number go up a little bit, but I think that between this and the 3D requirement, that it's going to be putting off a lot of people. So that gives us a slightly better edge. Also, the fact that we're going to be doing preparation today. So nothing specific to the game jam itself, but we're going to be tooling a finite state machine, doing some work with input handling, and possibly even a player controller. So between today and tomorrow, I will be streaming several hours putting all of those together inside of Unity. These are things that could be useful in not just this upcoming project, but many other projects as well. We're going to try and make them modular so that we can use them for 2D, we can use them for 3D, we can use them with do-tween or rigid bodies or anything along those lines. That's the goal, at least. What other announcements do I have to make? Oh, yes. So if you would like to play our previous Game Jam submissions, so we have the Lost Relic one, we have the Pirate Software one, and we have the most recent GMTK one. For the GMTK one, I recommend you download the desktop version and use a gamepad for the best experience. But if you would like to play any of those, circuitstudios.itch.io is the place to go. I will pin a link into the chat. We also have a link in the description of this video. So if you would like to give us feedback, just as we have given you feedback, we would greatly appreciate that. Just close some of these down. Also, just a reminder, we only do the live feedback stuff following in the immediate aftermath of game jams. If you would like more personalized feedback, the ability to participate in monthly Q&As, private member streams, or even consultations, you may subscribe to this channel, go down to the links below, join our membership on YouTube, or Ko-fi or Patreon, And at higher tiers, you will be able to participate in all of those things. So, what other announcements do we have to do before we get underway? Yes, our schedule for the week is going to be changing slightly. So, as I said, today and tomorrow, I'm going to be suspending doing normal videos in favor of doing live stream dev tooling in preparation for the upcoming game jam. Saturday, I'm taking the day off. There will be no stream. I am going to use that time to review previous streams, throw some timestamps on whatever ones I can, reviewing our Cult of the Lamb stream, because on Sunday we're going to be returning to play Cult of the Lamb. And I am very anxious to see if they had any new changes made since the recent Unholy Alliance DLC. I know that there are a couple of nice quality of life features that I'm very much looking forward to. Eventually we'll get to playing local co-op and doing Genocide Run as well. What else do I have to talk about? Oh yes, since the competition starts on Tuesday, we're moving our normal art stream from Tuesday to Monday. So Monday will be art stream coming up this week. Not sure what we're going to be focusing on, probably more thumbnails. But we will leave that to till then. So in the meantime, let's get some music going. Turn the music down just a little bit there. That way you can still hear me, but you'll still know that the stream is running. Let me know in the chat if the music is too loud or too quiet. So, I just have a new project opened here for Finite State Machine. So the first thing we're going to do, create a folder for scripts, create a folder for input, and we're also going to create a README document. So the README document is just going to be some pseudocode, new file, simple text file. Okay, so this is going to be our to-do list. So build input handling, build finite state machine, build player controller, modular character controller, build sensor systems, so sight, sound, distance, collision, okay. So the character controller is going to be using interfaces, move, jump, dash, detect, patrol, attack, so entity, class, entity, data, SOs. Okay. New input system. Action maps. Control schemes. Control rebinds. Gamepad. Mouse. Keyboard. Virtual mouse. So we had a little bit of an issue with some of this stuff during the GMTK Game Jam, so if I can get some of this at least reasonably working, then I think that'll be good. Game settings, music, sound effects. Full screen windowed mode. Again, I'm not sure that we'll get to necessarily all of this, but anything that we can do here will definitely help us going forward in this and other future projects. A lot of this stuff will also be useful for when we go to do Alchemask as well. Oh yes, I should also mention that we have a hard deadline of 9 p.m. today, just because I have to go and see to one of my teacher's streams. So we'll be ending come 9 o'clock Eastern Standard Time, so roughly 6 hours from now. So not a full 12-hour stream today. We'll see maybe tomorrow, depending on how things go and how much we get done here. Accessibility, screen shake, invert controls, difficulty level, trying to think what other things doesn't. So for the state machine itself, we're going to need, obviously, state machine class, state class, iState, base, iMover, iJumper, iFlyer, etc. Dependency injection. Transitions class. Transition logic. Okay. Possibly states as scriptable objects using strategy pattern. Optional animation events. So there are a number of finite state machine tutorials out there. This isn't necessarily going to be a tutorial per se, but we are going to try and combine some of the best of all of them. So Animator Hell class there refers to Lost Relic Games video, the Escape the Animator Hell. We're going to be looking at Barden's stuff. We're going to be looking at Barden's stuff. We're going to be looking at Gitamen's stuff. We're going to be looking at a couple of different people's stuff. None of them, as far as I'm aware, have a transition class. I know that Jason Wyman does. I actually, from a previous project, have some of that already. So I already have some of this from a previous scene, so we may be able to reuse some of that. For instance, our collision checker, things like that. All right, so let us see if we can start with the input handling. So the idea here is that I'm going to build this in a tooling project, and in theory we should be able to export all of it as a package and then just import that into any other project that we need. Hey Quinn, you'll be hanging out for a bit? That's good. I'm just writing up our basic to-do list here. Where did this save to? I want that in the assets folder. Thank you. There we go. Okay. Get rid of that other one. So today is not going to be anything particularly stressful. Just doing as much as we can get done in that time. I am still a bit haggard from the competition. So excuse the yawning, excuse the weariness. Okay, so we need let's make a canvas. Package manager. I kind of want them to have this just sort of built in by default going forward. maybe in 2023. How's your card game going, Quinn? I know it was a bit of a late night for you last night. Yes. We should probably, since we're going to be making lots of scripts, do a smart and import hot reload. That would probably be a good thing to have. And V hierarchy. Currently on hold until the team decides on the project future. Okay, makes sense. Go to my assets. Hot reload. Import. Maybe we should leave V hierarchy off for now. Because as nice as it is, we want to make this modular so that we don't have to do anything with it. Interesting. Most code changes, but there are some limitations. Generally, changes to the method definition and body are allowed. Non-method changes like adding and editing classes and fields are not supported. See the documentation. Okay. Okay, so input. Input actions. Go to the event system. Copy this. Let's just copy both, I guess. Plugins, don't need that. Gamepad. Save. All control schemes. Add. Mouse. Okay, and for the gamepad, I think something that we didn't do last time was we forgot to add a virtual mouse to this. Make that optional. Okay. So for the virtual mouse, so stick action. Add binding, virtual mouse position. Yes, those are all gamepad. Joystick, gamepad, 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 keyboard, W. Hmm? Yes. Okay. So these need to be for keyboard, and then virtual mouse. Pointer. virtual mouse. So left button for that. And virtual mouse should be for keyboard. Scroll wheel. So submit should be button south. Button east on the gamepad. Right, east makes more sense for that. I guess we can look it up, what's the most common. Most common cancel button for gamepad. Some are saying X button, some are saying B button. Xbox controller. So B on the Xbox. Right, that tracks to east, and PlayStation controller. They're saying X. Wouldn't that normally be like submit though? All right. All right, we'll just go with button east, since for me that makes the most sense. Save. Save early, save often to save a life. Left mouse button. So we have the virtual one. Mm-hmm. Alright, we'll just leave that for now, because we mainly just need the left and the stick. Right, so back to player. Right, so we have move for left stick. These all need to be for keyboard. So look, right stick, yep. Delta pointer. All right, let's get rid of these. And get rid of fire. All right, so move will be left stick. I guess delta pointer would be like the difference between moving here and here. Let's just add more actions here. Say jump. Space. And south. Button south. Okay. Let's just call these north for now. Call this east, call this west until we decide what they mean. Right trigger. Let's do left trigger, right trigger, left bumper, right bumper. Left trigger gamepad. Right trigger left bumper. Shoulder. Right shoulder. Okay. Okay. Select. Pull that L3, R3. Right, so save that. So that should be most everything mapped to the keyboard, or sorry, the control stick. All right, we'll leave that for now. All right, so you need a visual. It's image. Virtual mouse icon. Um, all right, let's just get rid of all that because that was on the wrong thing. So create empty. Mouse. And image. Virtual mouse icon. And that needs to be there for both. commit. Roll. Cancel. Right click. Middle click. Forward. Okay. And then this, forget which of these needed to be on the lower left. Let's check. All right, so the transform needs to be on lower left. Just speed this up a little. Right, zero everything out. All right, fine. All right, make that raycast target none. Very important. Okay. And what else? Yep, got that. Zero it out. Drag the graphic, we already did that. Yep, standard input module. Keep doing that. Event system. controls. Something I didn't think about during the game jam was the reason why the first menu worked was because we had first selected set, but when I transitioned to any of the other menus, it didn't have that. Interesting. That's something I hadn't considered. Okay. Kind of wish that the scaler would default to scale with screen size for 1920 1080, given that that's like the most common one nowadays. Especially since everybody's doing YouTube and most monitors are calibrated to that. Mm-hmm. Right. Let's go to here. Say create C# script, virtual mouse controller. Help URL. Okay. Make sure. What is it? It's that. Make sure your canvas is to scale with screen size 1920 by 1080 with this set in the game mode as well. Create empty game object as file of canvas with virtual mouse script attached to it. Set transform size to 0, pivot to lower left. Set up new input system controls in event system game object. Set bindings for virtual mouse, making sure all fields are filled. or it will throw an error and break in a build. Set up new input systems. Create child image of virtual mouse game object. Set icon. Add outline. Icon size. Add outline. Turn raycast off, or it will glitch out. Assign icon to visual and transform fields in virtual mouse component in the inspector. Okay. And then I think we attached this script to the object itself, but we'll see. Okay. What else? Right, setting that. Input controls, set virtual mouse position for point and mouse left button for click. Hey Leshy. Oh, Quinn, if you're still here, tell Leshy how you added her to the, or him, I guess, to the game that you're working on as an enemy that you could fight. The one forest creature with like the deer skull. We were playing that last night on stream. Okay, yep. Set that, got it. Yep, turning raycast off. He set all of his to cancel. Other options, match, right, middle, and scroll. For forward and back, you can just use cancel if you don't. Yes. We also have ferrets. Let's not forget the ferrets. Right, we know it's broken, and just skipping to make sure you know what you're doing. What was that set to before? Okay, that's something I didn't do. If using virtual mouse, set UI navigation to none, and instead use the virtual mouse. Set move in event system none, or UI navigation if not using the mouse. Okay. Yes, meme. The way you said that in chat kind of reminds me of Beaker from the Muppets. It was like, me. Right. So now he's getting into the script where he uses it to confine it to the screen. All right, so attach that to the regular game object. Mouse component. Okay. All right, I'm gonna move this over here just so that I can see at the same time. Okay. So awake. Virtual mouse input. virtual mouse input. Copy that. Equals get component type of virtual mouse input. Column to the server. Position equals put dot virtual mouse dot position dot value yes. Position dot x equals mathf dot clamp position dot x 0 screen dot width, and same for height. But for y, just rename that to input. Okay, anything else? Yeah. Just gotta set it back. Input state.change. Okay. Okay. Is that everything? Then he's got to do the scale. Okay. All right, so serialize field, private rect transform canvas transform. Okay. Void update transform dot local scale equals vector 3.1 times 1 over canvas transform dot local scale dot x. Right, and set as last sibling. As last sibling, not first sibling. Okay, and what else? Anything else? Right, and we have to scale the visual still. Direct transform virtual mouse visual So duplicate that. We'll say virtual mouse visual dot scale equals the same thing. All right. That's about to come to an end anyway. So what is going on here? This is his bindings.
In my game, I can seamlessly swap between mouse and gamepad controls. Note how the virtual cursor only shows up when I actually touch the gamepad. So here's a code for how I identify which input is active in my game. I've got a general game input class that does lots of things regarding input, but the important thing for identifying that one is I simply have an enum, so just a game device, so it can either be the keyboard, mouse, or the gamepad, and then I simply got a field for the active game device. Then down here on the awake, inside the awake, I subscribe to this event, this callback, the on action change inside the input system. This one is going to get triggered pretty much anytime the player touches any input, so that is going to call this function over here. And then on this function, this one takes two arguments, and one of them is input action change. So here I'm basically just testing the actual phase for the action. If it is an action performed, if it's not, then I'm just going to ignore it. So if it is an action performed, then I'm basically going to ignore if it is a virtual mouse, because again, I'm only trying to test between the gamepad and the actual mouse. So if it is a virtual mouse and I don't care about it, I'm going to ignore it. If it isn't a virtual mouse, then I'm going to check if the input action control device, if it is a type gamepad. So if it is an Xbox controller or a PlayStation or Switch or anything, if it is a gamepad, then I'm basically going to change the active device to gamepad. And if it is not, then I'm going to say that the keyboard mouse is active. Then this function over here, this one just sets the active game device. Then I also either show or disable the regular cursor based on whether the keyboard mouse is enabled or not. And then I'm going to fire off this event on game device change. And then I have this other script, which is pretty much exactly the same thing that we saw, the virtual cursor UI script. And then on this one over here on start, I'm listening to that event on game device changes. And when that changes over here, I'm really just updating the visibility. And I'm really just checking the game input instance. If the gamepad is one that is active, then I'm going to show it. If not, then I'm going to hide it. And that literally just enables or disables this game object. So yeah, this is how I handle swapping between mouse and gamepad in my game. So for that, I'm going to...
All right, let me just copy this down. We'll deal with that another time. For swapping between control schemes. Okay. So let's get this back. And all right, so that should be everything apart from attaching our script here. If let's do void start canvas transform equals get component in parent. That's not going to work because var canvas equals get component parent canvas transform equals canvas dot get component. Have a rect transform. And then we'll say virtual mouse. Bar icon equals virtual mouse visual dot get, or just say get component in children image. So then we'll say virtual equals icon dot get component rect transform. Okay. So if we do get component, it should tell us if it's null. So in theory, we shouldn't have to actually transfer that to do it automatically, as long as it's set up correctly the same way every time. Okay. So now that that's done, let's work on our actual state machine, shall we? Well, that finite state machine. All right, so we're going to need C# script for state machine. Move you off to the side so you don't keep bothering me. Okay, C# script for state. And let's just make a folder for interfaces, a folder for scriptables. Let's call it SOs. C# script for transition. Trying to decide whether we want entity now or wait on abstraction. All right, before we get into that, I'm just going to go use the bathroom because we've been going about an hour and a half already. So I will be right back. We are back. And I brought some coffee because I could feel myself getting a little bit tired. But we want to stay up for a good few more hours, at least 5 more hours. Alright, so we were transitioning to working on our finite state machine. So we got a folder here for FSM. So we got a folder for interfaces, SOs. We'll make one for states. Even though the states will probably be SOs. Make one for data. All right, so for our states, state's going to be abstract class. Doesn't need to be mono behavior. So for this, we're going to have a couple of methods. So public virtual void enter exit going to say logic update, physics update, going to say do checks. So in case we need to do like a ground check or a wall check or something like that. And that's actually going to happen in our logic update. And then we can call base.logic update and add anything else that we want to it. Let's see. What are some of the other state methods we might need? I guess we'll call this on enter and on exit. So public virtual void do animation trigger. So if we have any animations, and then public virtual void on animation finished. So not every state will necessarily need this. In fact, we could just call this on trigger and because then we can call it from anywhere. So for instance, we can use the animator to have animation events that call this, or we could have ones that say like on animation finished. And then it does other logic. Trying to think if there's anything else that we might need to do as far as the state is concerned. Because each type of state is going to keep track of its own references. and we're going to use dependency injection. Oh yes, also need a constructor. Public state. So then any child states can override or inherit from the base state when we construct them. So we'll say public class moves our idle state. Inherit from state. Say move state. What else? We could have jump state, fly state, swim state. We could have states for anything that we want, really. I'm just trying to think of the most common ones. Dash state. Fly state. Maybe we want to have ones that are like an action. It's a grounded state. So for instance, idle could be a grounded state. If I spelled it correctly. So then like grounded could be anything that involves a ground check. But let's just leave it as state for now. And we'll say public void in air state. So unlike a lot of other state machines, our states are not going to worry about the transitions. They're not going to worry about the animations. Public virtual void play animation. We'll just leave that empty for now. Because not everything will necessarily have animations on it. We may want to use this for other things. Say public class hack state, public class knocked back state, class invincibility state, maybe that's not a good one to have, because that'll necessitate a lot of other things. So like maybe within the attack damage it could be right, that should be good enough for now. So for our state machine, going to have a public state or current state, get private set, public void change state, and so this is going to say if state equals current state, return, right? Because we don't want to transition to the same state. So at some point we're going to want to say that. So we change the state and then we say state dot on enter. And for the previous one, we say current state dot on exit. So anything that needs to get called when it's exiting, we change the state and then we call on enter. We're also going to need a list of transitions. So let's go to our transition class, because that's going to tell us whether we can change state or not. And let me see if I can open up my previous project where I was working on this. All right, so this is what we had for that. So let's just take all of this, copy that. All right, so we have a from state, we have a to state, and then we have a condition. And then in our other state machine, so we also needed a constructor. This was also not a mono behavior, I don't believe. Right, so since it's not a mono behavior, it needs a constructor. State machine. Okay, so we have our dictionary of transitions. Add a transition from one state to another. Then paired with a list of... Yeah, we can also say if that's null. That's fine. All right, so state machine, add transition. All right, so we're saying to add a transition from this state to this state with this condition. So func, if you've never seen, is just a delegate. It's like an action that returns a particular type. So in this case, it's returning true or false. So if transitions doesn't contain the current, if it doesn't already contain an entry for from state, then we make a new one. And then we set that with this transition. Okay. And then at some point we need to call should transition. So that's probably going to be an update. Right, so every update we're calling logic update. And every fixed update we're calling physics update. So that's easy. Private void update. So if current state's not equal to null, current state dot logic update, and then fixed update, private void fixed update, if current state's not null, then current state dot physics update. Okay. All right, so then for each transition in our dictionary, if we should transition, we change state. Okay, that's easy enough. And because you're not a mono behavior, we should call this logic update. And this physics update. Okay. So the way this is going to work is that any entity that uses a finite state machine, it'll start off by constructing all of the states it needs, then it'll construct all the transitions it needs, it'll create a new state machine, and then it'll initialize to probably idle, or whatever its first state is supposed to be. And then every update, it'll do a logic update to check for transitions, and if it finds one, then it'll change state. And every fixed update, it'll do these physics updates for any state that has physics update information. And in fact, let's move all this up to here. Okay. And so far we're not actually using this yet, so let's not worry about that. So that's it for our state machine. We'll just leave a little note for ourselves there. All right, and so the transitions. Okay, so let's go into our test script here. So we'll say state machine, and we'll just say idle state transition so in start we'll say state machine equals new state machine, idle state equals new idle state, move state equals new move state, move from idle equals new transition from idle to move state. And then here we can define the condition. We'll just for now say bool is moving, or let's just say float movement. Move input. Say move So we're moving if move input is not equal to 0. And then here we call state machine dot logic update. These need to be public. So here we create states. Here we create transitions. Here we assign transitions. So we'll say state machine dot add transition. So idle state, move state. So we don't actually need to do that. We can just assign it here. I'll say move input not equal to 0. Like so. All right, so that's as simple as it is to create our finite state machine. And then we need to say void fixed update state machine dot logic physics update. And the reason I'm calling them physics update and logic update as opposed to update and fixed update is just so that we don't get confused about the fact that they're not mono behaviors. So mono behaviors very explicit. Mono behaviors very explicitly use the Unity lifecycle, which includes update and fixed update. You could, of course, do that. It's perfectly valid. But at least this way it's clear that we're talking about the state or the state machine's methods as opposed to a mono behavior's methods. So in our idle state, actually in our change state method, let's just log current state. So every time we change state, it'll let us know that we've changed into a different state. So back in our test, At the very end of all of this, we can say state machine dot change state to idle state. So that'll be our very first one. Okay. Let's just put our camera and our lights here. Okay. And just because I like to keep the hierarchy organized, we'll create empty. This will be test. And so let's add our test script onto you. And we'll actually make this a serialized field. Not sure what I was spelling wrong there, but okay. Okay. And let's also make one a transition where we go from move state to idle state, and we'll say if move state is equal to 0. So we have idle to move and move to idle. So within each of these states, we can have arguments that we pass through to the states in their constructors. So for instance, if we had a state that, let's just say for sake of argument, public class move state rigid body 3D. We could say something like public move state rigid body 3D. In fact, that's pretty verbose. So let's make it RB3D. Okay, so that'll extend move state. Can't remember what the order of this is. Right, so after the arguments. so let's just say that this is going to need a rigid body, 3D. Right, something like that. So we can pass in as an argument rigid body, RB. And we would say it extends base move state. Move state. So this dot RB equals RB. And does it have to be override? Oh, I see. Right, so this would be the new constructor. So we're making a specific version of move state. So it's going to have all of the base things that a regular move state does. Except that it's going to have a rigid body. So we pass that in. And then we just do the regular constructor as well. So this is adding on top of the base constructor. So then we can do something like public override void physics update probably also want to store velocity, private float velocity, or it might have to be vector2 velocity. Vector C is a vector3 velocity, I think. RB dot velocity, yeah, equals velocity, and then public override void on enter. So we would need some kind of entity. Right, so the other class would have its velocity. So let's just say velocity. This dot velocity equals velocity. And so we wouldn't just pass this in directly, we would pass in a reference to whatever the entity is that contained that velocity. And we would store that. Right, so we'll say right, so test entity this dot entity equals entity, and then we would say equals entity dot velocity, and then of course we would have to have velocity on here. So let's just say, for sake of argument, public vector3 velocity get private set. Okay. And so then we would be able to query the entity's velocity every time. And then back in our test here, we would say move state that. Again, that's pretty verbose. I probably would only just have one variant. In fact, let's do that. So let's just call that the move state. And so it'd say, instead of that, it's that one. And then we would have public rigid body. Yep. Pass that in, and this for the entity. And then we can do all our transitions from there. Right, but for now, let's just test this one. Just to make sure that's working. But essentially that's how we would use dependency injection to inject all of the things that we need in there. And so anything that the state needed, it would just get injected into here. So if we needed an animator, we would inject the animator. If we needed collision senses, we would inject the collision sensor. Things like that. And so the base entity becomes very sleek in that regard. And as you'll see, it'll be even more sleek once we start adding core component systems. Thank you to Bardent for coming up with that system. All right, so let's just test this for now. Okay, so when we hit play, we should expect to see the console saying that we entered idle state. Let's not do maximized mode. What are we trying to create? Transition is not a mono behavior. Okay. All right, let's just save that. All right, so now we should see that here. No ref exception. We'll also say if current state equals null, return. Actually, no, because the very first time it will be null. Right, so if we didn't already have a current state, we don't need to call on exit. All right, so that should work. Right, that's just downstream of that. Just recompile you to make sure that you lock in those changes. Okay. Okay, so we changed to our idle state. So now if we make this literally anything other than 0, there's our move state. And if we make it back, we're in idle state. There we go. We have a fully functioning finite state machine. And from here, we can just extend it with whatever states and transitions that we want. So, all right. So now we need to make some states. and some transitions. Before we get into that, we should make our senses Okay, so for that, we're going to need a core and core components. Core. Move you away for now. Core component. I'm just checking my notes here. Right, so we needed also C# script core comp. Leave that off for now. So open all of these. Okay, so let's put some music on first. Okay, that'll be another half hour's worth of music for us. All right, so we don't need transitions open anymore. We don't need our state machine open anymore. Those are done. Eventually we'll have to do some work with the states class. And for now, just move you into your own class. Get all of these. In here. And just making sure I spelled transition right. So put all of this into basics. Alright, so don't need this anymore. We'll deal with our individual states later. So we'll say core comp, and this is just going to be sort of a helper method, a generic that extends where T is core component. The reason we're calling it core component instead of component is because component is reserved for Unity mono behavior components, whereas this is going to be completely within the finite state machine system. So we don't need any of this. Private core private T public T So if there is a component, we're going to get it. Otherwise, we're going to say get component get core component, and we'll make this method in a second, and we get that by reference. And then we have a constructor, public core comp, if core is null, debug.log error, core is null for component type of e.name. Just say that. And if it's logging an error, it should automatically break that. Otherwise, this.core equals core. Okay. So in core component, This will be a mono behavior, but it'll also be abstract. Yeah, this is just a helper function, so it doesn't need to extend mono behavior. Protected for core. Public pool. I guess we could say public core. Make it a property. Start awake. Okay. Public void initialize. This.core equals get component type of core. Get component in parent type of core. Game object dot set active based on whether it starts awake. Okay. Virtual void logic update. Do we need physics update? I don't think we need physics update. Should just need logic update because we're not doing any rigid bodies or anything on these. Although it couldn't hurt to add it. Most of the time it'll just be null. Or empty rather. Okay, so that's the base for core component. So the way that this will work is we'll have a game object in the hierarchy underneath our entity that uses this. And it'll say core. In fact, let me just show you because that's easier. So we'll say create empty. That'll be core. And then connected to the core will be all of its core components. So things like, you know, movement component, fences component. What other components might we have? Animator component, things like that. So these will all trickle up into the core. The core will filter all of them, and then the core will send data back to the state machine. And then we can add as many of these as we want and customize our entities that way. Okay. So that should be it for these two. And then we need the core. So let's just make this public void get core component. So we stop getting this error. Core components. This needs to be generic. So similar to how get component works, we're going to do get core component. And this will be type T. No, still no. We need to say where T extends core component. Public T get core component type of T ref T value get core component return value. Okay, so we have one where we just get the component and the other where we get it by reference. So for this, we'll say var comp equals core comp. Before we do that, so private read-only list of core components. And the constructor public core right, so just how like an object in the hierarchy has a list of components and you can get the component from the game object, so too we're going to have the core and it's going to have a list of core components as child objects and we'll be able to get those. Alright, so here we're going to say var comp equals core components dot of type T first for default if comp return comp and type of T not found on Okay. Um, dot name. All right, so we're going to get the core component by type from the list. In theory, we should only have one of each. That may become an issue down the line if we want to add more. And then, so if we find it, we'll return it. If not, we'll just say it wasn't on that particular entity. Okay. So now, protected virtual void awake. Public void logic update. So for each var component in that, we're going to say component.logic update. Very good, thank you. Public void physics update for each var component that physics update. This is basically the equivalent of like the Maru behaviors. We have awake, logic update, physics update. So awake update, fixed update. Public virtual void setup. So if there's anything we have to do there, protected virtual void initialize. All right, so this is equivalent to like start. In fact, let's put these up here. Region, life cycle, wake, setup, init, logic update, physics update. And region, okay. Region components. Add get or add and region. Okay, so just how game objects have add component and try get component, that's what we're going to make now. So public void add component, core component, And we're going to say if it's not already in our list for components, right? If it's not already in our list, we're going to add it. We may as well remove as well. If for components dot contains component okay. So we'll say public void get in parent or almost for components or comp equals transform.parent.get component in children if comp it's not null, add component comp. We could just say return add component. Okay. So we're going to say modifier add component to be generic and then just return it. Otherwise, All right. So that was a lot, but that should be everything that we need for the core system. And again, consider adding entity to constructor. All right, so that's the core system done. Then we want specific types of cores. And this is actually going to start transitioning into our player controller. Be a little bit more explicit about that. All right, so go back to Unity for a second. So on our core, okay, that's just going to sit there. And then in our test script, we could say public core. And we can either, we can either add it via serialized field, or we can do this. Core equals get component in children type of core. Because we filed the core to this object, it should find it right away. Okay, and then we need to say core.logic update, core.physics update, and so that'll update all of our components. So core dot can't remember why we needed this, but right, so we get our core, we initialize it. Was core supposed to be a mono behavior? I believe so. Yes, so you would never have a constructor. Okay. Yeah, so initialize here is equivalent to start or on enable or something like that. And what else? Music, that's what else. And may as well add these. I just say ball extended. First sun ball extended. Second sun Aim extended. One who waits. I really should make this like a saved playlist, since I listen to this quite often. Hey, Super Rad Maker. I am doing well today. So we are working on, let me just get this kicked off. We're working on a finite state machine system, a modular one at that, so that for a bunch of different games, we can have entities that use states and transition between those states rather than having to hard code the same thing every time. So we're prepping for the Sasquatch Beast Studios Game Jam, which I know is going to have 3D characters in it. So we will eventually need a 3D character controller. And possibly our game Alchemist will also use a 3D character controller, so this has multiple uses. So I will show you what we have so far. So we worked on setting up input controls. Here we have our finite state machine package. So we have our basic state machine. Excuse me. Oh, it's opening in the wrong one. There we go. So we have our state machine. So we have a current state, a list of transitions, and then we can change state. And when we do, it'll trigger exiting on the previous state and enter on the new state. We can add transitions, and then we can perform logic checks and physics checks. And then each state will go through a bunch of different phases. So it'll enter, exit, it'll do checks. So for instance, if we need a wall check or a ground check, that kind of thing. Then it'll perform its normal update functions. It'll perform physics-based functions. If we need it to animate, we'll do that. If we need it to trigger certain events, we can do that as well. Then we built transitions, basically just going from one state to another on whatever particular condition that we set. So if we go back to our test script, oh yes, and then just having a bunch of placeholder states for now, showing off how we could eventually expand the logic of each individual state on its own and use dependency injection. So if we need it to get a particular component or get particular data, we feed that in. And so then just showing off how we would set all this up. So we're working on the core system right now, which I'll go over in a minute. But then we create our states, we create those transitions. So right now we only have one that toggles between move and idle. So if our input is not 0, then we go to move. If it is, then we go back to idle. And then we call change state. And then in our update method, we're doing all the logic checks, and in physics update, we're doing all the physics checks. And then, like I said, we're working on the core system right now. So just filling all that out. And the way that's going to work is we're going to have an entity that uses a finite state machine. So basically any entity that we want to go from one state to another, it'll have a core, and the core will just be basically a glorified lookup table to get all these various components that will do different things. So if we want something to be able to move, we'll add a movement component. If we want something to be able to sense its environment, we'll add senses components. If we want something to be able to animate, we'll add animation components. And that'll all just feed back into our system here. So very modular, very flexible, very useful. We can do lots of things with it. So if I come over here right now and watch the console, so it's going to initialize to our idle state. Right? See, it said that our current state is idle. So now if I come here and I modify our move input to literally anything, see how it transitioned into the move state, and then if I set it back to 0, then we go back into idle. So from there, it's just a matter of hooking up the logic in each of the individual states to decide what we want to have happen in that particular state. So for instance, in idle, we might have like an idle animation where it's just kind of bobbing up and down. You know, if we're idle for a certain period of time, maybe we keep track of that, and then he'll do like little idle dances, or he'll fall asleep. Things like that. In the move state, it would depend on how we structure our movement. So if we want to use rigid bodies to do physics-based motion, we could do that. If we wanted to just control it directly, we could do that. So working on that right now. And then again, we can have a state for pretty much anything that we want. So these are just some of the ones that I came up with off the top of my head. Right, so idle, move, jump, dash, fly. Are we on the ground? Are we in the air? Are we attacking? Are we getting knocked back? We could have a death state. All right, so whatever states we want to come up with, then it's just a matter of figuring out, mapping out how we go from one to the other. So that's what we're working on today. You're very welcome. What are you working on today? Oh, thank you. I appreciate that very much. Also, if you guys come up with any other states that you can think of, let me know, and I will add them to the list of potential states that we could do stuff with. I guess like swim state would be one. We could do sleep state. Going back to what I was saying before about going from idle into sleeping. There was also one that I wanted to do from like any state, maybe. You just finished streaming, did a workout, played with the dog outside, played some guitar, made a beat in Fruity Loops, and was thinking about working on your ASCII roguelike game or your robot dog. Wow, so you've had a very busy and productive day already, I see. Public class landing state. Public class falling state. Call this guard state. You're new to programming, so it's slow motion, but better than no motion. Yep. As long as you're making forward progress. Okay, that is also way too many spaces there. I don't like the look of that. Also you. Okay. I'm just gonna leave these all here for now. Until they get so bloated that they need their own classes. So we don't need you anymore. Public class pause state. That could be a useful one. That's weird. I thought my keyboard was getting hot for a second. Trying to remember, I forget how we're supposed to actually get all of these. I guess we'll figure it out. Alright, I am going to take a quick bathroom break, and when we get back, we will start working on some core components. So don't go away. Alright, I am back, and I know we said I was going to work on our core component system, but something I just thought of, which might make a lot more sense, is instead of making these data classes like this, and having to create all these individual transitions, what if instead we just made them into scriptable objects? I think that would probably be better. So make state scriptable object. Would help if I didn't delete the class name. Okay. So then all of you create asset menu. File name equals menu name equals and we're not going to worry about sort order for now. Before we go crazy with that, actually, let's just make sure these actually work the way I intend. So idle state and move state. That way we're not going totally crazy and we can always revert back. But as scriptable objects, they need to be in their own folder. I'm sorry, their own script, rather. So all of these ones for now. We'll go over there. Let's come back to our test script. And instead of doing this, what if we just say All right, so then we don't have to actually create new ones. Just drag them in. Maybe we do the same thing with state machine. Create asset menu. Equals state machine. Menu name equals okay. So back in our test script, shouldn't need this. And then, assuming that this works, we should be able to do the same thing for our transitions. And then the only thing that we would have to input at that point would be the funcs themselves. All right, let's try that out, see if that works. So we should, top level statements must precede namespace and type declarations. Oh. Because we're in play mode. Create a folder. FSM. States. All right, so we should be able to create a finite state machine. Test FSM. Hello. Interesting. Kmod state, that's not correct. Okay. So on our test, and assuming this works, then we can probably just add that to the state machine itself with like a list of states. And possibly a list of transitions. All right, so test. Okay, so let's see if that works. Okay, so we're in the idle state. Now we're in the move state. Now we're back to idle state. Cool, so we successfully turned our states into scriptable objects. That's much more design friendly. Let's see. Because now our individual states can hold data. Let's see. So now we should probably do the same thing for transitions. This is only ever referenced in this class. Serialize field, private state from state. All right, so we're just going to make a little helper here, a public getter, if you will. In fact, why don't we just say get uState. We don't actually need to do that because it knows that this is a property. Yes. It's just a property getter. So now the only thing the transition should need is that let's do this instead. And we need to do the same thing here. I mean, I guess I could just make it public, but this is a little safer. That way it'll never accidentally assign it in code. Okay, all of that should still work the same. So transition, create asset menu, file name equals transition, menu name equals finite state machine / transition. Okay. Okay, did it just not recompile? Scripts have errors. Oh yes, of course. Ah! So probably what we would want instead is rather than creating a new one, we just set that current one. We say dot condition equals condition. Public void set condition. Yes. Okay. And then we just say add transition. We should probably make a function for like with to say with condition. Well, let's just test to make sure all this works first before we start messing with that. Okay. So now we can add a transition. Idle to move. Move to idle. Okay, so we have our two transitions. So idle to move, move to idle. We would probably want to make this a component as well. So just like we have a movement component, we could have like a transition component. All right, so let's test. And that is not registering now. Okay. State machine. So it's not reaching that. All right, that's idle to move. Let's move to idle. All right, let's see. Huh. Curious, it did it that time. All right, so now... Okay, so now we're in the move state. And now we're back in the idle state. Move, idle, move, idle. Okay. I'm content that that works. I just don't know why it wasn't triggering the first one. Okay, all right, so let's go back into our transitions and we'll say public static transition with this transition. Func bool condition dot set y. Yes, return transition. Say with start. With from. With to. State 2. I mean, at this point, we may as well just say public. We'll just set the to and from. State 2. To state equals 2. State from state equals from. Set from. Set to. Welcome back, Leshy. You accidentally fell asleep. Was I boring you? Right, that's not used anywhere. What is unhappy now? Extension method must be defined in a non-generic static class. Fine. Public static class. Transition extensions. Happy now? Okay. So in our state machine, instead of saying this, we should say transition dot with condition. Alright, fine. I thought I could be clever and just say with, but I have to be explicit. Go to our test script. And this should all still work. Okay, and to move into that, that, that. Okay, very good. Well, let's not collapse you for now. Okay. Can I say this? I cannot. Why can I not? So let's do state machine. Return this. Now I should be able to chain them. Yes. So then I can just continuously chain them together like that. So get rid of that. All right, what's the next phase of this that we want to do? What else can we abstract out here? I guess now we work on individual states, maybe? Go back to our movement controller. Input. We'll say C# script game input. So I need that open. So I need to remember how to do this using Unity Engine dot input system. Where is the go back to what we had in Gravity Drive. Be under users. Sets. Scripts. No. Controls. No, not that one. This one. All right, so start by making an instance. Game in. Put instance with a capital. Thank you. Do I want our our singleton script. I guess for now it doesn't matter. Hey Alex! In early September, you will be meeting with the team that you worked on Shrouded Legends with. We'll be discussing what our next steps will be in the process of turning it into a longer game. Very nice. You meeting up in person, I assume? Online, okay. Alright, so... Public static player input. Player input. Public static controls. Because we did not generate the C# class. Alright, 6:30, so we got 2.5 more hours to go. List actions. So public static vector to move, get private set, public static vector to look, get private set, public static bool, jump down, jump held, jump up, move, look. And region. Okay. There's going to be a lot of them. East. west. Left trigger. Start down. These will be select. One, two, three, four. What do I call this? Shoulder. Shoulder. Right shoulder. Right trigger. So basically what I'm doing here is taking all of my input actions that we are able to remap and rebind to different keys, and I'm just making fields for them on the back end so that I can get them easily through code. All right, let's start. Select down. L3, R3. And by doing it this way, I will have a suitable framework to just copy this over into other projects with minimal changes that have to be made. South, north. So basically, if you've ever used Unity and you're familiar with the axis system, so like, you know, get axis.horizontal, get axis.vertical, get axis.fire, submit, etc. That's essentially what we're recreating here, but with the new input system. So if I ever decide that I want to rename these to something more user-friendly, so for instance, when we did Gravity Well, or Gravity Drive, I changed these to X, Y, and Z. And pitch, yaw, roll, all that stuff. In fact, we could probably do that as well. Public static float horizontal. Public static float horizontal or vertical. Call this move X, move Y. Let's just do that for now. And actually make this horizontal. No, we'll leave it that. All right. And another region for static actions. Submit, cancel. Call this gameplay actions. Call this UI actions. And region. So pretty much all of the time that I spend doing this now is time that I don't have to waste during an actual game jam, which is helpful. Okay. Vector 2. Vector 2. Scroll wheel. And point, I believe. Yeah, so navigate, point, and scroll wheel are vector 2s. Submit, cancel, click. Vector 2. Point. 2, 3, 4, 5. All right, so submit. Cancel. Click. Middle click. All right, submit, cancel, click, middle click, right click. Okay. So then at worst, for any individual project, I just have to go through and rename some of these. All right, that is a lot of things. Hey, Nut Dealer. How would I ever make a video on Smack Studio or 2D animation? Oh, would I ever make a video on Smack Studio or 2D animation and rigging? Well, first of all, I'm not sure what Smack Studio is, so if I were even contemplating making a video on that, I would first have to research what it is. As far as 2D animation, my abilities as an animator are pretty limited. So I know a couple things, but really I'm not the best person to do that at this moment. I would have to go and learn and figure stuff out. Actually, since we're listening to this, something that I do want to look into at some point is Massive Monster the Lamb animation stream. Somewhere out on the internet, Massive Monster has a 16-hour-long stream of them doing a good chunk of the animations for Cult of the Lamb. I might actually have it saved on my other list here. Ah, that's why. It's unlisted. So here's the uncut animations for the ritual process. So you can have a look at that if you want. Okay, so back to what we're doing, which is input system. All right, so then we're gonna have a massive friggin' update loop. Public or private void update. And then public static void get current action map. Player input dot current action map. Accidentally weren't watching me live, so don't really know what I said for the Smack Studio thing. So what I said was, I don't know what Smack Studio is, so if I were to make a video of it, I would have to go and research it first and internalize and understand it before I could even present it to any of you. The only other alternative would be like if I were to learn it live on stream, which I don't know how fun that would be. And as far as 2D animation and rigging, my knowledge of that is pretty limited. However, the link that I just posted there is to the 16-hour-long stream of the developers over at Massive Monster making the entire, or a good portion of the animation for the sacrifice ritual in Cult of the Lamb. So that would be something worthwhile since they do 2D animation in Unity and it requires character rigging and skinning. Oh, is that the one that, actually I might have heard of that, actually. Where it does 2D pixel animations. I think I might have heard of that. I had something in the Discord. Might have been in the dev-only streams. Is it under art? Maybe it was in the lounge. Dev lounge, cool stuff. Sorry, give me 1 second while I look this up. Under learning, maybe? Might not have posted it on our Discord. I might have posted it in Pirate Software Discord, thinking about it. Which is possible. Anyway, I'm not going to waste time looking for that right now. Yeah, as far as adding bones and rigging and stuff, you can do that directly in Unity. At least for 2D stuff, especially. Would I be able to give an online guest lecture for a college Godot workshop that we're organizing? So I don't know Godot, so I don't know how well that would go over. Also, I don't really have the means of traveling to wherever it is that you are, unless you're in the tri-state area around New York. Oh, online guest lecture. I mean, as long as it doesn't involve me needing to know Godot. When is this supposed to be? Google Meet? Alright, let's put this in here. So September, I'm doing 2 game jams. So it would depend. It would depend on a lot of things, but firstly it would depend on getting a fixed date. Because I also have, actually one day during one of the jams, I have to be in court. 13th. That might be during the Brackies game jam. So I'll lose a day from that. I don't mind being disturbed on stream. It gives me something to talk about. And maybe other people watching would be interested in getting a hold of you on our Discord. If I can't do it. September 9th? That's probably too early. That's like right between the game jams. So I'm probably going to be prepping for Bracky's game jam at that point. Or, is that a Monday? Yeah. Probably prepping for the game jam. Alright, now to go through and fill out all of these. Okay. So move equals player input dot actions dot read value vector 2 look move x equals move dot x look x equals x. Jump down equals player was press this frame held up directional buttons what do we say this was north east west okay. You want to participate in Bracky's Game Jam, but you won't have a team, as all are real tired right now. If you're able to learn procedural mapping by then, it will be solo. Why does it require that you learn procedural mapping? Why can't you just use the Game Jam as an opportunity to learn how to do development on your own and then just narrow the scope of your project to something that's manageable? Right, so like I've often talked about the Orticino collection. Right, so you've got these little very simple games here that you could try to replicate. Each of them is simple enough that you should be able to do them in a week, barring the art style. But you should be focusing on making a prototype anyway, so the art style doesn't matter, that's just polish, that's just icing on the cake. Because you want to learn procedural mapping for one of your projects, it would be cool time to implement that. Okay. You can certainly try to do that. Or you could do like what I'm doing right now and just make it a standalone thing as prep work, right? So you don't have to wait for the jam. You could try and learn it on your own. All right, so we have the shoulders and the triggers. Oh. You're trying to make a real Souls-like slash roguelike game. That's why wherever you're participating, you're sticking to the idea of an RPG, you want to perfect it. Limited time keeps you motivated, and less time to think means I think quality instead of quantity. That is the reason I'm not participating in month-long game jams. So what I would say to that is, go back to our text document here. So if you want to make a complicated game like an RPG or a Souls-like, I would start by breaking it down into a bunch of different systems. So you have input systems, you have stats system, you have combat system, you have inventory system, you have quests system, boss system, level design system, level up system, equipment system. What are some other ones? PvP system, online network system. What are some other ones? Weapon system, field system, story system, interact system, right? And so you would break down this into a whole bunch of systems, and then in each individual project or game jam, you focus on perfecting one of these systems. So for instance, for our games, so we had Spellweaver, which dealt with the item generation from from database system to scriptable to JSON to scriptable objects. Right, so in Spellweaver, we figured out how to get item generation from a database to a JSON into scriptable objects. Then for Gravity Drive, we figured out voids. For this upcoming project, right, so for this upcoming one, we're working on figuring out how to do a finite state machine, how to handle inputs, how to do player controllers. We also have setting systems. Okay, so each one of these we're building up our knowledge and advancing along to eventually, when we make Alchemask, it's going to be a combination of a bunch of different systems. Right, so part of the reason why I'm doing all of these game jams is to build tools for myself that I can use in any project going forward. And also to... Oh yeah, we also learned the Poisson disk system from that for spawning items and upgrade system. I don't want to say that. Right, so the idea is that when we do Alchemask finally, it's going to be a combination of all of these different systems, and each of the game jams that I'm doing is helping me to develop tools to figure out what kind of problems I'm going to have to deal with in the future and how to automate around them. So like you look at all of the various tutorial channels, whether it's Code Monkey or Brackeys or Jason Wyman or Sasquatch Studios or Blackthorn Prod or any of those guys, right? Each of their videos focuses on a single system or even a subsystem of that system, right? So within combat, you have movement, you have dealing damage, you have things like knockback, you have dealing criticals, you have pop-up text for damage counters, you have dealing with death state, respawning, checkpoints, okay? All of that is just a subheader of the combat system. You could have other systems like weather, calendar, relationship systems. So so you cannot make a game. Making a game is too complicated. At best, you can go through and make one portion of a single system, and then that's within your grasp. And then you make another portion of that same system, and that's within your grasp. And you make a portion of a different system, and that's within your grasp. And you chain them all together like Legos, and hopefully you're building them out in a modular fashion so that you can pull one from here and plug it into the other one. And they just snap together using some kind of a bridge or dependency injection. And that's how you wind up building a game. So think about something like Cult of the Lamb. Okay. So you have your follower system. You have the combat system. You have the farming system. You have the resource harvesting system. You have a boss system. You have upgrade system. You have a worship system. What else? You have the ritual system. You have the doctrine system. Weapons system. Ability system. Stats system. Wardrobe system. Weather system, because it sometimes rains in Cult of the Lamb. Tarot card system. Relic system. Did I say weapon system? What else? Quest system. Health system. Animation system. What else? Grid system. Because building the buildings operates on a grid. A lot of things operate on the grid. Map gen system. What else? Room decorating system. So similar to something like the Spelunky algorithm or the Isaac algorithm, you have the map at large that builds out a bunch of rooms, and then each room is responsible for decorating itself. Okay. What else? I'm sure there's tons and tons of more systems in there that I'm forgetting. Right? But each one of these on its own is pretty complicated. So in order to build this, you first would have to build each and every one of these plus more that I'm probably forgetting. And that's how you ultimately build up a game. Oh, dialogue system. That's its own thing. And each of these systems can tie into other ones. Tutorial system. Right, ones that you wouldn't even think about. Audio system. So, and that's broken down into music system and sound effects system, maybe even a fanfare system. So you have announcement system. So like on the sides, when little banners pop up, alert system. Right, so it's one thing to have an upgrade system. It's another thing to have an upgrade system that sends you little announcements every time you've leveled up. It's one thing to have a follower system. It's another one to have an alert system that lets you know when your followers are hungry or losing faith or dying. Right? So tons and tons and tons and tons of systems. More recently, they have the co-op system. They have the breeding system. They have the sin system. Hunger system. Faith system. Right? Because hunger is its own separate stat. Faith is its own separate stat. Different events like rituals tie into faith. Losing people dying to hunger causes it affects your faith. So all these systems tie into each other. Death system, right? Your characters can die, they can grow old, they can get buried. People can revolt, depending on whether you are, whether they're averse to ritual sacrifice, or whether they're averse to people growing old, depending on what doctrines you set out. So, if you're planning to make a game, a very complicated game, break it down into all these different systems and work on those one at a time. And make them modular enough so that you can hook any one of them up into any other one. And that's how you build complicated games. Yep, cutscene system. That's its own system too. Alright, speaking of systems, back to working on our input system. Alright, so... Alright, so left trigger, left shoulder, right shoulder. Right, so the entire reason why I'm doing this, why I'm spending today working on plotting out all of this, is so that I only have to do it once, and then I can just take this and plug it into every other future game that I ever want to make. Right, so remember the other day we were talking about Tim Kane's idea of code the rules, script the exceptions. So these are going to be the rules. And then for each individual game, I may have to rename some of these, but that's trivial at that point, since I have most of it already mapped out. Right? I may have to choose a different button mapping, for instance, but that's trivial at that point, compared to going through and plotting out all of the base architecture. Left down, right, left, right. Okay. So, like, for instance, when we did the Boyds and Poisson disk stuff for Gravity Drive, I don't need to go and touch that ever again. I can just drag those systems in. So if I ever want Poisson disk sampling and Boyds in any future game, I could have them in every one of my games now. And it'll be trivial to set up. Alright, so start, select, and any key. Also, somebody note the timestamp on this. The, like, around 4-hour mark is when we start talking about this. So when I go back and clip that, this one was special. Or gamepad dot current dot all controls dot any x where x is button where x is button control button and x dot is pressed and not x dot synthetic. Okay, so then we should be able to just do the same for these. And instead of say was pressed, no? Um, is all right. I guess we don't have anything for that, so let's just rename this. Key pressed. Okay. Um. And then we have to go back here. And then we do the UI buttons. Okay. And copy that. And paste that here as well. All right, so navigate, scroll wheel point. Add single one dimension axes. UI positions. And how many of these do we have? 1, 2, 3, 4, 5. One, two, three, four, five. Four, five. Submit. Yeah. No, I didn't want to do that. Cancel. All right. Click, middle click, right click. Middle click, right click, right click. Okay. And any key pressed UI. Or actually, for any key pressed, why don't we just say actually it's the same name, so it shouldn't matter. Okay. So region gameplay and region. Hashtag region UI. Hashtag and region. Okay. All right. Now we have successfully made at least the basis of game inputs. So the next thing to do after that would be to create a rebinding system. So to do figure out key rebinding system, hook in hook into virtual mouse controls. All right. We won't be able to do most, probably pay you for. Also, we won't be able to most probably pay you for the session you take, and even if we can't, be like $50 or something for half an hour session as well. India ain't exactly a rich country. Oh, I'm not leaving yet. We've still got 3 more hours. Oh, you're saying you gotta go. Okay. Yeah, I probably won't be able to do that. So if you watch this back in the VOD, I probably won't be able to join you there. But you can take what I was saying before and clip that and play that for your group. Have them watch this video, this stream, and they can learn from that. I think that would be probably more valuable in the long run. Okay. Let's see. Uh, all right. I'm going to be right back. I'll take another break. And then at that point, we will probably work on doing some more stuff with our finite state machine here. So don't go away. All right, we are back. I've returned with ensalada, salad, then I have burgers coming later. Homemade. So I have that to look forward to after the stream. And then got just under 3 hours to continue working for today. So we're making good progress. Sorry, just had to adjust my headphones there a second. So, we are working on our finite state machine. We started turning our state machines into scriptable objects. So we have idle state, move state, and our transitions. Let's see. So, at this point, we probably want to work on the senses, because that's probably the next most important thing. Being able to detect stuff is always important. Hey, Shoot for Rank. Welcome to the stream. How are you doing today? As I just got finished saying 5 seconds ago, we are working on a finite state machine. Let's do movement core, since I have that one already queued up here. Movement core. Not that one, that's my reference. Okay, so we'll call this one, actually, no, not that. Rename movement core 2D. So we need a public rigid body 2D. Call that RB. Get private set. Public vector 2 current velocity. Public bool can set velocity. And public int facing direction. Vector 2 workspace. Get rid of all this. Alright, and this is going to extend core component from our core component system. Just a quick question. How did you escape tutorial hell? What makes you think I'm not still in tutorial hell? So like earlier in the stream, I was having to look up CodeMonkey doing a tutorial on how to construct a virtual mouse. But if you want advice on, in general, how to escape tutorial hell, the general way that you do that is you try and make... So you have your logic and you have your syntax, right? So logic is like, you know, if I do this, then I do this. If I do that, then I do this. And breaking things down in pseudocode in sort of like a plain English way. So if I were to explain to you what my code does, for instance, and say you knew nothing about code, that would be, you start with that and you figure out all of the logic, and then after that you try and apply the syntax to it, translating what you wrote down in the logic stage line for line into actual machine code that the engine or whatever you're working in can execute. And then if you run into a point where you don't know how to translate between one or the other, then just like translating from one language to another, you have to go and look that up. So you can start in the dictionary, quote unquote. So like the documentation for any particular code language or engine. So for instance, Unity has its own documentation. C# has its own documentation on the Microsoft website. So you could start there, read up on it, learn how the thing actually works, rather than looking up somebody's specific implementation of that one particular problem. But say that you can't figure it out from the documentation, then you can look up Stack Overflow, you can look up YouTube tutorials, you can look up in ChatGPT, for instance, but you're only looking up that specific problem. So say that you are coding an inventory system, right? And you have most of the stuff down, but you don't know how to call, let's say, say you don't know how to trigger when you click on something and you drag it within Unity, okay? But you figured out most of the other stuff for your inventory system, right? You've got a grid structure, you can set the icons and all that, but you just don't know how to drag and drop them. So then you would go and you would look up drag and drop, okay? And you'd find a tutorial on drag and drop. And then once you're done with the figuring out how the drag and drop portion works, which in Unity, for instance, is just like a simple iDrag, iDrop interface, okay? Once you figure that out, then you close the tutorial and you go back to working and trying to figure it out for yourself. That's how you ultimately escape tutorial hell. Okay. Hope that helps. Because the idea is you want to eventually internalize all this stuff. So when you're just starting out, obviously you don't know anything, so you need somebody to hold your hand and guide you through and teach you at least the basics of it. But hopefully as you learn and grow, you become more self-sufficient, you're able to figure things out on your own. You at least know where to look it up, or you know who to ask for help and to isolate that particular single issue that you're having. And hopefully as you become better and better, you start having fewer of those issues, and then you become the master. Okay, so back to what we're working on. So protected, override void, awake. Yeah, we'll call base.awake. Then we'll say get the component. Facing direction equals 1. And can velocity equals true. Okay, and then we need to override our logic update. Public override. We don't actually need that. Alright, so then we need the ability to set the velocity. Zero x y final. You are very welcome. Alright, so public void set final velocity. If not, then set velocity turn. Easy. So then public void set velocity 0. Um, float velocity, and this is direction. Equals velocity times direction. Okay. Public void set velocity x, float velocity okay. And then y is the same thing. So here we're setting velocity for x and y. Here we're just setting it for the x going left and right. Here we're just setting it going up and down. So for instance, if we wanted to just do horizontal movement, we would call this and set our running speed, or if we wanted to dash, for instance. Whereas Here, we would use this if we wanted to jump, for instance. Okay. So then we want a version of this. My implementation looks like Barton's finite state machine. Funny you should say that, because that's what I'm referencing here. Although I'm adding some changes of my own. For instance, Barton doesn't have transitions created as scriptable objects. He doesn't have his state machine created as a scriptable object. He doesn't have his states created as scriptable objects. He also doesn't have his animations set using Lost Relic Games' Avoiding the Animator Hell tutorial, where you set transitions through code rather than in the animator. He doesn't have extension methods to where you can set a custom condition to your transitions. So, using Bardent as a base, Alright, set velocity 0. Yes, also a little bit Jason Wyman. That's where I got the transitions from. So in our state machine, we have a dictionary of transitions. And we can add the transitions to them. So combining from multiple different sources. Good artists copy, great artists steal. The best artists steal from multiple sources to hide their tracks. Also, Barden doesn't like using expression body methods. He prefers block body methods. And he doesn't like inline guard clauses. Okay. I'm just debating whether to make this more comprehensive and just call it movement core. Although I guess leaving it as a 2D one is probably better. It keeps it leaner. And then we can make a 3D variant of it. Alright, I think that's everything for that. XY, yeah, we have all of those. So we'll make a public class movement core 3D core component. Just thinking whether we wanted to make abstract versions. I guess we'll do that after. Okay. So now, take all of this, copy that, change that to 3D, change that to vector 3, change that to vector 3, and then set a vector 3 for our facing direction. Transform.forward. Make that vector 3. Velocity or direction dot z times velocity. Why did we need this again? Right, because we're using that to flip him, but we don't need that now. I don't think we need that at all, actually. because that's just going to be what turn. Well, going to depend on how we actually rotate. So we probably have a separate thing to handle the rotation in that case. So get rid of that. So current velocity dot z. Current velocity dot z. This would be we're having like get amends vector 3 with x with y with z would be helpful. But let's just do this for now. Velocity z. Okay. Get rid of that. Okay. We'll set some more music up. Oh god. That's horrifying there. Have I ever used the event bus system? What do you think about this system? Is it too over engineering? So I've used event channels before. Event bus is a little bit above my pay grade still. I could probably figure it out if I dedicated time to, but at the moment it's still a little bit too complicated for what I'm able to do. But something like this, for instance, with event channels, I already implement that into a lot of my projects. But this is a little bit too outside of my range still. But we will be looking at Git amend stuff probably tomorrow when we start implementing character controller. I'm probably just gonna straight up rip off his design or see what I can integrate with this. Like, I get the idea behind a bus, because it's just like in Factorio, you have a main bus, and things can just pull off of it from wherever. But as far as the actual implementation of it, it's still a bit confusing for me. Alright, so we have our movement core. Trying to recall exactly how we implement those. Let's see, do we need anything else in the transition class? I don't think we do. So we can get rid of that. Do we need anything else in the state machine class? I don't think so. Actually. Okay, I was wondering why there was double brackets there, but that's fine. I did have something for animated states as separate, which is something that Bardent also didn't do. Probably pull this in. Get rid of all that. Let's take all of this. So this is something that Bardent doesn't have. So rather than strictly limiting us to a circle collider or a box collider, this can use any type of 2D collider, and it will still register whether it's touching something, and we can set a layer mask for it. So it's a little bit more dynamic. In fact, let's just rename that to 2D. I don't think it works quite the same for 3D. Let me look that up real quick. Google Unity contact filter 3D. Looks like there's no equivalent for 3D, unfortunately. So for 3D, let's rename this actually to sensors. That's effectively what that is. Public class. So for here, this will require type of box collider. Actually, can I just say collider? Collision checker greedy. Private void awake. Collider.isTrigger is that. And then just like this, public tool is touching get private set. Private void on trigger enter. We'll say if not is trigger, return. Can I add a... No, I cannot. I need a layer mask. Just be explicit about that. We don't need to save real estate. Same with you. Oh, right. That's why we did that. Okay. Use expression body. Use expression body. Serialized field. Private bool. This trigger. I think we want to default that to true. Right, because it's a sensor, not a collider. I'm just trying to think if there's ever a time when we wouldn't want it to be. So we'll say private void on collision enter. And if you are a trigger, then we return. Let's say is touching. Say is touching equals um this is doing on trigger stay. So all right, so then we need to figure out how to actually do the check. If physics dot overlap do we want to switch here? Maybe we say call dot no. Is Can I do that? And physics dot overlap box. Say col dot center, col dot transform dot I think what we might have to do so if col is box collider, then we'll say box cast wow, this is annoying. Alright, so what if we say box collider. This is kind of a stupid way to do this, but got box, capsule, mesh, Alright, so what if we said box equals try get component, box collider, outbox, okay. So we will try to get one of those four. Pretty sure those are the only four that you could have in 3D. also just arrange them in hierarchy. Okay. So we'll say if not box and not mesh and not sphere and not capsule dot log error no collider found on trans dot name parent dot name. Let's just do that. Okay. Mesh sphere capsule okay. So say if box and physics.boxcast. I'm not sure what the difference between boxcast and boxcast all is. Like physics boxcast, but returns all hits. If any intersections were found. I think that's the one that we want. Alright, so if boxcast box.center box dot times 0.5. Overlap box center whatever box dot transform dot rotation contact mass not equal to null. Okay, now will you tell us what... Alright, let's just look up the documentation, since we were talking about that before. Unity documentation, overlap box. That's probably right. Okay. So if mesh actually, you can just say if collider or if other dot game object dot layer. How do I check if layer contains? Unity check if layer mask contains layer. All right, so bit shifting. So if mask and one bit shifted to layer is not equal to 0. Okay. Mask and one bit shifted to other.gameObject.layer is not equal to 0. Why don't we just say yeah, that was correct. Cool. Touching equals that. What? Oh, okay. That. Okay. Okay. So do the same thing here. All right, let's put some more music back on. What shall we listen to, chat? We have 30 minutes left before I have to end the stream. We'll do Gold Palette and then Cascade. And then by the end of that, that should be the end of the stream, and then I have to go. But we will be back tomorrow to continue all this. Alright, so this was some complicated bullshit. That easy. This bullshit. Right, I forgot I could just do that if I've already cast the type. Okay. Alright, so we have collision sensors. We have our core movement. We don't have core rotation. So let us do class somewhere in here I had was it this? Yes. Okay. Um. Okay, and add those. So as field, have it transform target. Public vector target position. Get private set. Public void set target. Transform target. This dot target equals target. Why? Oh, duh. So private void awake if target not equal to null, target position equals transform dot position or target dot position. Um, don't need that. Um, make that mono behavior. Um, hmm. And so then public void, or no, I'm sorry, public class, look at camera. Let's do this instead. Public transform target. Protected void awake. Public enum camera type main player UI let's not do that for now. Public pool main camera. Protected override awake if main camera target equals camera, not main, not transform, base dot make. Let's see. Is there something else I wanted to add to that? No, that was just the distance. So this will be if we want to look at a particular transform. This will be if we want to look at a particular position. Let's see, what else can we make in like 5 minutes? Public class Vision sensor. Let's go back to our idle state here. And we'll say public float idle time. Mm-hmm. Um, Maybe we want a timer. Add folder abilities. We'll have to maybe do that tomorrow. All right, we're in the final stretch. We're in the home stretch, boys and girls. About 10 minutes, I will be ending. I mean, we'll pick this up again tomorrow. All right, so move state is going to require public movement Actually, maybe we work on interfaces real quick. So interfaces. Although I thought I had made let's go back to Unity. Reload. Alright, so iMover is just going to have a public void move. Just void move. Okay. Public interface by jumper. Public void jump. Public bool can jump. Public bool can move. Public interface by flyer. Public interface, bool. Public void dash can dash. This will be public int num jumps. I forget, you can't have fields in an interface, right? No. Okay. Uh, Public interface I damage bull. Public int health bull can take damage. All right, what else? What else? What else? Got move, jump, dash, fly, swimmer, I guess. Public interface, swimmer. Right, what other states do we have? Knockbackable. Um, all right. All right, that's quite a lot of stuff for one day, I think. Anything else? All right, I think we're going to call it there, ladies and gents. We will pick this up tomorrow. So we did all of that. So test input system. Test change control schemes. All right, we did that. We did that. Animation, date system, animation states, animation, string class, core component. Build out individual state classes. Test 3D collision. Test 3D, or I guess we'll just say movement core. All right, those will be the things that we wind up doing tomorrow. So I hope you will join us tomorrow, where we will continue more of this in preparation for the Sasquatch Beast Studios Game Jam. Until then, I'm Maru Dark. This is Circuit Studios. Take care.